Think you know where palm trees can survive? The truth is staggering. Ireland sits at the same latitude as frozen Labrador, yet tropical plants thrive in its gardens, while Newfoundland remains locked in ice. This defies everything you would expect from geography. The numbers do not lie. Dublin averages 9 degrees Celsius year-round, while Labrador, at the identical latitude, shivers at -5 degrees Celsius. That is a 14-degree difference that should not exist. Meanwhile, farmers in Cork harvest crops in December, while Canadian soil stays frozen solid for months. The answer starts with an ocean current most people never imagine could rewrite the rules of an entire continent. Ireland sits at 53 degrees north latitude. To understand how impossible this island's climate really is, you need to see what else exists along that same line around the globe. Think of Hudson Bay in Canada, frozen solid for half the year, or the southern tip of Greenland, with ice sheets and tundra. Think of central Siberia, where temperatures plummet to -40 degrees Celsius and stay there for months. Yet Ireland's farmers grow potatoes through winter. The physics behind this anomaly centers on one massive force. The Gulf Stream delivers 27 million cubic meters of warm Caribbean water past Ireland's shores every single second. That is equivalent to 150 Amazon rivers flowing continuously, carrying heat from the tropics directly to Europe's doorstep. Take Newfoundland, same ocean, same general latitude as Ireland's southern coast. Yet St. John's averages -5 degrees Celsius in January, while Cork enjoys 7 degrees Celsius. That's a 12-degree temperature gap between two islands separated by the same Atlantic waters. The Gulf Stream creates this impossible divide. As it flows northeast from the Caribbean, it releases enormous quantities of heat into the atmosphere above Ireland. The prevailing westerly winds then carry this warmth inland, transforming what should be subarctic conditions into something resembling southern England. Historical temperature records from the 1700s reveal just how dramatic this effect becomes. Dublin's winter temperatures consistently measured 15 degrees warmer than comparable northern cities. Cork rarely saw sustained freezing, while Quebec City endured months below -10 degrees Celsius. The current itself moves at staggering scale. Oceanographers measure its flow at 30 times the combined discharge of all the world's rivers. This liquid conveyor belt transports heat equivalent to 1 million power plants operating continuously, all focused on warming Europe's western edge. Yet the system operates on a knife's edge. The Gulf Stream's path shifts with atmospheric pressure, solar cycles, and deep ocean circulation patterns. When these forces align incorrectly, Ireland's impossible mildness can vanish overnight. Satellite data shows the current's precise route varies by hundreds of miles, seasonally. During strong phases, warm water pushes further north and east, bathing Ireland in tropical heat. During weak phases, Arctic air masses invade from the northwest, overriding the ocean's warming influence entirely. The temperature differential becomes even more extreme when you look at coastal waters. Ireland's western shores maintain 10 to 12 degrees Celsius at the surface through winter. Labrador's coast, on the same latitude, falls to near freezing. This 10-degree ocean temperature gap translates directly into air temperature differences that reshape entire ecosystems. Modern measurements confirm the Gulf Stream's power extends deep beneath the surface. The current carries warm water down to 1,000 meters, creating a massive reservoir of heat that keeps warming Ireland's climate even when surface conditions shift. This thermal engine operates year-round, but its effects peak in winter, when the temperature contrast between the tropical source waters and their northern destination reaches its greatest intensity. The result turns Ireland from an Arctic island into Europe's mildest climate zone, completely defying latitude-based expectations. The evidence is overwhelming. One ocean current rewrites the climate rules for an entire nation, creating agricultural possibilities that should not exist, and supporting millions of people in a place that by latitude should be uninhabitable tundra. The Gulf Stream's power becomes clearest when it fails. January 1740 proved what happens when this thermal engine falters, even briefly. Irish farmers expected a normal winter, their usual mild conditions, perhaps some rain, maybe light frost. Instead, Arctic air invaded from the northwest and stayed for 28 months straight. The Gulf Stream had weakened dramatically, allowing polar conditions to override its warming influence entirely. Rivers froze solid across the island. The Shannon, Ireland's longest river, became a highway of ice, thick enough for horses and carts. Mills stopped turning. Coastal trade halted as harbors locked in ice. Ships carrying grain from Europe could not reach Irish ports, cutting off the lifeline that fed millions. The economic collapse was immediate. Grain prices exploded 280% above normal levels as supplies vanished. Wheat that sold for 12 shillings per barrel in 1739 cost 45 shillings by spring of 1740. Barley and oats followed the same trajectory, placing basic food beyond the reach of most families. Livestock began dying in massive numbers. Sheep in Connaught froze in the fields. Cattle across the southern counties could not find unfrozen water or edible grass. 1/3 of Ireland's dairy cows failed to breed that year, destroying milk and butter production for the following season. The cascade effect rippled through every aspect of rural life. Spring of 1740 brought no relief. The weakened Gulf Stream could not restore normal weather patterns. Instead of the usual mild, wet conditions that supported crop growth, Ireland endured an unprecedented drought. The autumn-sown wheat and barley crops, normally harvested in summer, withered in the fields. Potato crops, already expanding as dietary staples, rotted in the ground. The death toll mounted relentlessly. Conservative estimates place mortality at 300,000 people. More likely, 480,000 died. Nearly 1/4 of Ireland's total population. This exceeded mortality rates anywhere else in Europe during the same period. France lost 600,000 people, but from a population of 24 million, Ireland's losses represented proportionally the worst demographic catastrophe in 18th century Europe. Contemporary accounts describe scenes of mass starvation. Families abandoned farms and wandered roads seeking food. Cities overflowed with refugees from rural areas. Dublin's workhouses couldn't accommodate the influx. Cork's merchants reported empty warehouses and desperate crowds. The crisis exposed Ireland's total dependence on Gulf Stream stability. Unlike continental European countries with diverse food sources and established grain reserves, Ireland had built its entire agricultural system around the assumption of mild, predictable weather. When that assumption collapsed, the island's population faced extinction. International relief efforts proved inadequate. Britain, fighting the War of Austrian Succession, couldn't spare resources for Irish aid. European grain exports were banned to protect domestic populations facing their own shortages. Ireland stood alone against the climate catastrophe. Recovery began only when normal Gulf Stream patterns returned in late 1741. Warm water resumed its northeastward flow, restoring the atmospheric conditions that made Irish agriculture possible. The 1742 harvest succeeded, but the damage was permanent. Emigration surged as survivors sought more stable environments. Population growth, which had driven expansion for decades, stagnated. The Great Frost demonstrated the fragility underlying Ireland's apparent climate advantage. One ocean current disruption transformed Europe's mildest island into a death trap, proving that geographic anomalies create vulnerabilities as well as opportunities. The Gulf Stream's warming influence created agricultural possibilities that should not exist at 53 degrees north latitude. Irish farmers developed an empire built entirely on this climatic anomaly. Potato cultivation became viable at latitudes where the crop normally fails. The extended growing season, stretching from March through November, allowed multiple plantings and higher yields than anywhere else in northern Europe. By 1800, potatoes supported 4 million people on an island that should barely sustain subsistence farming. Dairy farming thrived in conditions that should freeze livestock solid for half the year. Irish cattle grazed outdoors through winter, while Scandinavian and Canadian herds required months of indoor shelter. This competitive advantage transformed Ireland into Europe's premier butter exporter, shipping dairy products across the continent from Cork and Waterford. The grass itself grew differently. Gulf Stream mildness supported active grass growth for 10 months annually, compared to 6 to 7 months in continental Europe at similar latitudes. Irish pastures stayed green through December, while English fields turned brown. This extended grazing season reduced feed costs dramatically, making Irish livestock products cheaper than competitors. Grain exports flourished despite the northern latitude. Irish oats, wheat, and barley shipped regularly to Britain, France, and Spain throughout the 18th century. The climate supported autumn sowing and early summer harvests, timing that maximized market prices when continental crops were not yet ready. The growing season itself defied latitude-based expectations. Irish farmers planted in February and harvested through October, gaining 2 to 3 months compared to similar northern regions. This extended season allowed crop rotation systems that maintained soil fertility while maximizing output per acre. Modern Ireland continues exploiting this Gulf Stream advantage. The island now ranks among the world's top butter exporters, shipping dairy products to over 100 countries. Grass-fed beef commands premium prices in international markets, leveraging the year-round grazing that the current makes possible. Yet climate scientists detect troubling signs. The Atlantic meridional overturning circulation, the deep ocean system driving the Gulf Stream, has weakened to its lowest point in over 1,000 years. Satellite measurements show the current's flow decreasing by 15% since 1950. Temperature records from the past decade reveal the first signs of change. Irish winters are becoming more variable, with occasional Arctic intrusions breaking through weakened Gulf Stream defenses. The winter of 2010 brought Ireland's coldest temperatures in 30 years, as polar air overwhelmed the current's warming influence. Agricultural vulnerability is increasing. Potato yields fluctuate more widely than historical norms. Dairy production faces periodic disruptions from unexpected cold snaps. The grass growing season shows signs of shortening, particularly in northern counties where the influence of the Gulf Stream weakens first. The empire built on warm water faces an uncertain future, as its thermal foundation shifts beneath changing ocean circulation patterns. This ocean current created an agricultural empire where none should exist. But the Gulf Stream is weakening to its lowest point in 1,000 years. Subscribe to discover what happens when geography's greatest anomaly finally fails.